Hello viewers, in today's session we are going to discuss the differentiability of mod of tanx at x is equal to 0, right? So here to check the differentiability of mod of tanx at x is equal to 0, what we will do, we'll find out the left hand derivative and then we'll find out the right hand derivative, and we'll see whether the left hand derivative and right hand derivative both exist and they are finite, and moreover both the derivatives should be equal to each other. Suppose we have a function, say y is equal to f of x, and we wish to check the differentiability of this function at some point, say x is equal to a in its domain, right? And to check the differentiability of the function at this point, we find out the right hand derivative, and the right hand derivative is given by this limit, that is limit h tends to 0 f of a plus h minus f of a divided by h, right? And then we find out the left hand derivative. So the left hand derivative is given by this limit, that is limit h tends to 0 f of a minus h minus f of a divided by minus h. So if the right hand derivative and the left hand derivative both exist and they are finite, and the right hand derivative is equal to left hand derivative, then we can claim that the function is differentiable at the given point, that is x is equal to a, right? And if any one of right hand derivative and left hand derivative is not finite, in that case also we can say that the function is not differentiable, right? And in this case we'll find out the right hand derivative, left hand derivative at the point x is equal to a, and here our point is x is equal to 0, so we have x is equal to 0, that is a is equal to 0. So the function is f of x is equal to mod of tan x, and at x is equal to 0, the value of f of 0 is given by mod of tan of 0. So tan 0 is 0, so we have 0, right? Okay, so now the right hand derivative is given by limit h tends to 0. We have f of 0 plus h because a is 0, and here we have f of 0 divided by h. So this is limit h tends to 0. This is f of h, and f of 0 is 0. So here we have 0 over h. So this is limit h tends to 0 f of h divided by h. Now f of h can be obtained by replacing this x by h. So we have limit h tends to 0, and we have mod of tan of h divided by h, right? Now see, this quantity h is infinitesimally very small, and this quantity is positive. So h is infinitesimally small, it is positive, and it lies between 0 and 1, right? So mod of tan h is here we can use the definition of mod function also. So mod of tan h is simply positive tan h, right? So here we have plus tan h over h, and this is the well-known limit. So limit h tends to 0, tan h over h is equal to 1. So here we have used this limit, that is limit theta tends to 0, and we have tan theta over theta is equal to 1, right? So the right hand derivative of mod of tan x at x is equal to 0 is given by 1, right? So we can also use this notation, that is f prime of 0, and here we can write a positive sign. So we have f prime of 0 positive is equal to 1. So this notation is for the right hand derivative. So now let us find out the left hand derivative. So left hand derivative is given by this limit, that is limit h tends to 0. We have f of 0 minus h. Here a is 0, and here we have f of 0 divided by minus h. So this is limit h tends to 0, and this is f of minus h. F of 0 is 0, and here we have minus h. So f of minus h is given by mod of tan minus h, and here we have minus h, right? So f of minus h can be obtained by replacing x by minus h. Now we know from trigonometry that tan of minus theta is minus tan theta. So here we have limit h tends to 0 and mod of minus tan of h, and here we have minus h. Now mod of minus tan h is given by positive tan h, and here we have minus h, right? Okay, now we can take this negative sign in front of the limit notation. So we have minus the limit h tends to 0 tan of h over h. Now due to this result, this limit is equal to 1, so we have minus 1, right? So the left hand derivative of mod of tan x at x is equal to 0 is given by negative 1, and the notation for the left hand derivative is given by f prime of 0. Here we put a negative sign, and this is minus 1. So viewers, from this discussion we have seen that the right hand derivative is not equal to the left hand derivative at x is equal to 0, because here we have 1 and here we have minus 1, and 1 and minus 1 are not equal to each other, right? So we can conclude that this function mod of tan x is not differentiable at x is equal to 0.